Marginal cost and fixed cost using the fundamental theorem. One application that naturally lends itself to the fundamental theorem of calculus is the idea of studying the cost function when we know some information about the marginal cost and the fixed cost. So suppose that C of Q represents the cost of producing Q items. That's the cost function, the original function that we're interested in knowing more about. The derivative, C prime of Q, is the marginal cost, or the derivative of cost. Since marginal cost is the rate of change with respect to quantity Q, the fundamental theorem says that our integral to represent the total change will look like this if we're looking for the total change between A and B. So that's what we get if we apply the fundamental theorem directly. But if A happens to equal 0, so if we're looking for the cost to produce any number of items starting from 0, then we get the integral from 0 to B of C prime of Q dQ equals the cost at B minus the cost at 0. But remember, the cost at 0 is the fixed costs of the function. The fixed costs are the costs you have to pay before you've even made any of your item. So that's the point where Q equals 0. So that means that if we want to get the cost to produce any certain number of items starting at 0, the cost to produce B items, it's going to be the fixed cost plus the integral of the marginal cost. But the integral of the marginal cost is called the total variable cost. So that's how much you have to pay once you're actually producing your items. It's called the variable cost because that cost depends on how many you're making. It depends on your B, whereas your fixed cost is not changing. So now that we know this idea, we can take this second version of the equation. We do fixed cost plus total variable cost equals the cost to produce one specific amount of items. Let's do some applications and see how this works. Example 6. So we know that the derivative of cost is the marginal cost. So suppose that the marginal cost of an item is given in the graph below. So for part A, we want to set up an integral to represent the total cost to produce 150 items of this product. So that means we want an integral that's going to represent C of 150. So we know from before that the cost to produce any specific number of items here, which we're looking at 150, is going to be the fixed cost plus the variable cost. So that's going to be the integral from 0 to 150 of C prime of Q dQ. So again, this is just a rearrangement of the fundamental theorem. We could have written this as the integral from 0 to 150 C prime of Q dQ equals C of 150 minus C of 0. It would mean the same thing, but we took out one step by moving that C of 0 over. Part B. Use the graph to estimate the total cost to produce 150 items of this product. So we're looking for the variable cost here because we're looking at what's happening in the graph. And we want to know how much it'll be to produce 150 items. So it looks like a pretty good way to estimate this will be to break it up into this rectangle and this triangle. That'll give us a rough estimate, but pretty close to what we need. So the area of that rectangle is 150 in width. And then notice that these lines represent 2 units each. So 2, 4, 6. So it's 6 units high. So if we multiply 6 times 150, we're going to get 900. And then we want to approximate this triangle over here. So here we can see that the base is 100 units long. And then the height, so here we were at 6. And we're going up until, let's see, this is 10, 12, 14, 16. So from 6 to 16 is 10 units. 10 times 100 times half is going to give me approximately 500. So this is just one way to estimate. We could also approximate the number of blocks and then multiply by the area of one block. But we can use various ways and they should all be relatively close. So that means that the variable cost to produce 150 items is going to be $1,400. So it's the sum of those two numbers. So part C says, suppose now that there's an additional fixed cost of $1,000 to produce this item. What is your new cost to produce 150 items? So now I'm using the fact that my cost to produce 150 items is my fixed cost, which is $1,000, plus my variable cost, which I said was approximately $1,400. So that means it's going to be approximately $2,400. So part D says, suppose that you can sell this item for $25. Write an equation to represent the revenue function and find the total revenue for selling 150 items. So if we're selling this item for $25, that's a price. So that's P. And remember, revenue is price times quantity. And we're saying here that the price is $25. So my revenue equation is 25Q. So if I'm interested in my revenue when I sell 150 items, I'm going to do 25 times 150, and that's going to give me $3,750 in revenue. So that's how much money I take in from selling 150 items. Part E, find the total profit earned by making and selling 150 of this item. So remember, profit is revenue minus cost. We just found the revenue in part D, so that's $3,750 minus, now we said the cost was approximately $2,400. So we take the difference between the two and we're going to get $1,350 in profit. So that's not bad, right? Our profit's positive, which is always good. And our costs are not too high, so that's good as well. And we were able to find all the pieces we need to approximate this using the fundamental theorem paired with the graph of the derivative. Let's look at another example. Example 7. The total cost in dollars to produce Q units of a product is C of Q. Fixed costs are $20,000. The marginal cost is given by 0.005 Q squared minus Q plus 56. Estimate C of 150, the total cost to produce 150 units. So again, C of 150 is going to be C of 0, fixed cost, plus the variable cost to go from 0 to 150 of the marginal cost. So 0.005 Q squared minus Q plus 56 dQ. So, do we know all these numbers? Well, we know that C of 0 is 20,000. That's our fixed cost. And we can get our variable cost by plugging in this function into our calculator to get the area under the curve. So when we plug that all into the calculator, we're going to get $2,775 in variable cost, which means my total cost is $22,775. So $22,775, which again is the fixed cost plus the variable cost. Part B. Find the value of C prime of 150 and interpret your answer in terms of cost production. So we're looking for the marginal cost when we've produced 150 items. So we simply need to take the 150 and plug it into our marginal cost equation, which again was the 0.005 Q squared minus Q plus 56. So when we plug that all in, we're going to get $20.01. So $20.01 per item. So remember, the marginal cost is a rate that's in dollars per item. That's always true when you're talking about economics because the dependent variable is always money in dollars and the independent variable is always quantity in items. So that means that when we are making 150 items, it's costing us an additional $20.01 for each additional item that we make. So to go from 150 to 151 items, it'll cost us another approximately $20. C. Use parts A and B to estimate C of 151. So here, we know the cost at 150, and we know the derivative of cost at 150, so we can use local linear approximation to determine an estimated cost for 151. So remember, we're going to use C of 150 plus C prime of 150 times delta T. So how far away are we moving from 150? We're moving 1 unit away, so we're going to multiply that by 1. So we'll have 22,775 plus 2001. And we add those together, we're going to get $22,795.01. So that's our approximation for how much we're going to have to pay if we move to 151 items based on the information we have about what was happening at 150 items. So we brought back our local linear approximation, which we learned about way back when we were in an earlier section and talking about how to use the derivative to find out other information. Example 8. The marginal cost in dollars per unit of producing Q units is given in the following table. If fixed cost is $10,000, estimate the total cost of producing 400 units. So we're interested in C of 400. Using the fundamental theorem, we know that that's the fixed cost plus the variable cost, which is the integral from 0 to 400 of the marginal cost. We know that the fixed cost is $10,000. In order to get the area under the curve, we're going to have to do an approximation. So we're going to do a left-hand and a right-hand approximation in order to get the best approximation. So our left-hand estimate, we're going to look at our table. Now notice we're only going until 400, so we're not using the entire table. So when we do our left-hand estimate, we're going to pick the rate on the left. So notice that our delta Q here is 100. We're talking about 100 units at a time. So we're going to do rate, which is 25 times 100 for the first 100 units, plus 20 times 100 for the second 100 units, plus 18 times 100, plus finally 22 times 100. When we add those all up, we're going to get a left-hand estimate of 8,500. We also want to do a right-hand estimate. So for each 100 Q units, we're going to pick the rate on the right. So we have 20 times 100 plus 18 times 100 plus 22 times 100 plus 28 times 100. And that's our last one. We don't use the leftmost point of 25, but we do use our rightmost point of 28. When we plug that all in, we are going to get 8,800. So we have a left-hand approximation and a right-hand approximation. And since we don't have any further information, we're going to use our best estimate, which means we're going to average these two numbers together. When we average 8,500 with 8,800, we get 8,650. So that's our best estimate for the variable cost, which tells us how much additional cost we're going to have in addition to our fixed cost based on the quantity that we're making. So if we add our fixed cost plus our variable cost, we get $18,650, which is our estimate for the cost of producing 400 items.